Hi guys, Mrs. H here. Today we're going to be looking at standards of measurement. Our focus question for this section is what units are used when measuring length, volume, mass, electricity, and temperature. So our vocabulary is standard, SI, volume, matter, mass, and density. So if you remember, we need to know what measurement is. So measurement is how much of something or what the capacity of something is. We can also look at what the dimensions of something are. So in order for us to have a measurement, we need to have a standard in which it's agreed upon. So how do we know if I measure a foot and I'm using the foot on my foot or the foot on your foot? That's not a standard because each of our feet is measured in a different size. But if I have a ruler is a set measurement. So this ruler is set. Every ruler that I buy is going to be this length. But every foot on a person is not the same length. So that's why it's really important that we have an exact quantity that we've agreed upon, that this is what the standard is for a foot. And that's how we compare our measurements. So it used to be, before this, it was the king's foot. So if I wanted to go and get yarn or I want to get a bolt of fabric, they would use the size of the king's foot. And depending on who the king was, you're not necessarily going to get the most money for or bang for your buck. So if I had a small foot and I'm going to spend $2 a foot as opposed to a really big foot, right? Then I'm going to get more for my $2. And so that's why we need to have a standard to compare all measure. Same thing with a yardstick or a meter stick. All meter sticks measure the same. A mile measures the same. So that no matter where you go, everyone knows what you're talking about and how far that is. And the same thing goes for a cup. When I'm baking, 1 cup of sugar, no matter what the recipe, it's 1 cup. Everyone knows what that measurement is. So measurement requires a number and a unit. So when I talk about 2 feet, there's 2 of these, and then the unit is the foot. If I have 4 gallons, that tells me how much, the quantity, the number, and of what. Because 4 gallons is different than 4 feet. So in this one, I have 3 barley corns. That's 1 inch. So again, we have the measurement and we have the unit. Now, in the metric system, which is what we use in the science classroom, and actually pretty much everywhere else in the world uses the metric system except for the United States and a few other countries. So in the metric system, or what's called the SI system, or the international, notice international system of units, uses the metric system. And it's based on a physics concept that's universal. So the length is actually the length between the equator that runs through Paris, and a very specific, they actually have a marker in Paris. It's in front of Notre Dame, that it passes through to the equator. And that's how we use a standard of measurement. So the length, that's where we get the standard from. In kilograms, again, it's the mass of a specific substance, plutonium, and it's again a standard. So what are our standards? What do we measure in? So length is meters, which is M, mass is kilograms or kg, time is seconds, S, electrical unit is amp. Temperature actually is Kelvin or K. The amount of a substance, that's mole. And intensity of light. So all of those we're gonna look at this week. But as we go through this semester, we're specifically going to be looking at length, mass, and time. So those are the big three that we're going to look at. We might get to a little bit on current, we might get a little bit to temperature, but we want to make sure that we're comfortable with length, mass, and time. So, metric system is actually really easy for conversion. Where in the United States, you have to know that 1 foot has 12 inches and that 3 feet is 1 yard. Where in the metric system, it's a base of 10. And so it's really easy to convert from, say, 1 gram to how many kilograms, or 1 milliliter to how many liters, because everything is about the conversion of 10. And actually, they all mean something. So, like, kilo means 1,000. Milli means a million. Centi, or not, yeah. So centi means 100, like century. So all of the prefixes have a meaning, and that tells you what the number is. And so the conversion in the metric system is pretty straightforward. So if we're looking at the prefixes and what their multiples are, so kilo is 1,000, and that's pretty much what we use on the big end. There is hecta and deca, but we don't use those very often. The ones that we do use is, again, kilo. Then going small, we have deci, centi, milli, micro, and nano. And nano is really small. You'll see different items, like different things are going to have different measurements. So for example, a cc, so centi, a centimeter. We actually use that. That's how if you have your blood drawn, that's the standard unit for how much blood you're gonna draw. We measure it in centa. If you're gonna use kilo is distances. So I'm gonna go from one house to another house, from place to place. So depending on what we're measuring would depend on what prefix we would use. And those prefixes can go with any base unit. So it could go with gram, it could go with meter, it could go with liter. So here we have an example here. So centi would be something that we would use instead of an inch. It's actually a little smaller. So 1 inch is about like 2.2-ish centimeters. 1 foot is about, I think it's 30 centimeters. And then 1 meter is about 40 inches. And so you have an understanding of what the measurements are in comparison. So volume is the amount of space an object takes up. So the volume in my cup, so that's a volume, and it's a liquid volume. So this one we would use liters. But what if I have my block here, right? My Post-it note block, and I wanted to find out the volume. Well, that's when we would use we would measure the length times the width times the height, and we'd multiply those two together. So what we would end up with is a cubed measurement, because if you look, it looks like a cube. It's 3-dimensional. So we'd actually, if this was, let's say, 10 cubic centimeters, because it tells us in that description that there's a volume there. And so whenever you hear cubic centimeters or cubic millimeters, that would tell you that this is a volume measurement, where this, the liter, would tell you it is also a volume measurement. And that's what I was talking about. And this is the really cool thing about the metric system. So if I take 1 millimeter of water and I actually measure the amount of space it takes up, it's actually equivalent to 1 centimeter cubed. So that's why we can use cubic centimeter and milliliter or liter to represent volume, because they're both the same. They're both measuring that length, that width, that height. So that capacity, how much, what's the capacity of the milk container? Another thing that we use with measurement, we can actually take two measurements and come up with something else, something like density. So I could measure the mass of this and compare it to the volume of this, and I would know then its density. So the density of a pound of bricks and the density of a pound of lead, the lead is much more dense than the feathers, right? Because why? Because we're looking at the mass compared to the volume. And so the mass compared to the volume is greater on the lead. And when we're talking about that, what is it that we're exactly measuring? Well, that's a measure of matter. So when I'm talking about density, we're talking about, well, what kind of matter is it made of? Is there a lot of matter in that space, or is there a little bit of matter in that space? I can also do that with displacement. So I can take my water and I can put an object in there and I can see how much the object displaces, and I could actually find the density, because how much that water moved when I put the object in there would give me my my volume, right? And then I could measure the mass of it. So when we're looking at density, what we're actually measuring is grams, how much mass, grams per centimeter cubed. And because we're taking two measurements, it's actually called a derived unit. So when I combined two or more measurements, I get a derived unit. So this is taking the mass and it's taking the volume, and I'm coming up with a new measurement becoming derived. This in itself, if I measure the volume, the centimeter by centimeter by centimeter, is technically a derived unit, although we often don't think of it as one. Okay, so the SI unit for time is seconds. That's pretty standard. There's really no other measurement of time. It's seconds, it's hours, right? Days, weeks, those are all standard units of measurement. Now, temperature, we're used to the Fahrenheit. Again, most countries don't use Fahrenheit, they actually use Celsius. But the standard unit of measurement is actually the Kelvin cycle, or the Kelvin scale. The Kelvin scale actually measures absolute zero. And absolute zero is when it's like the coldest temperature possible. That means that atoms are no longer moving. They are frozen. They've not even frozen, because frozen isn't actually the right word. I apologize. They are stuck in place. They have no motion whatsoever. And we call that absolute zero. And Kelvin starts at absolute zero. And so that's why we have the Kelvin scale considered the standard for measuring temperature. So let's go ahead and take a quick quiz. Which is an example of an SI unit? Feet, seconds, pound, or gallon? And our answer is seconds. Which of the following is an SI, is SI based? Inches, English units, powers of 10 or powers of 5. And that is a power of 10. 1/1000th is expressed by which prefix? Oops, it's not kilo. So is it kilo, milli, nano, or centi? And the answer is milli. Which of the following is not a derived unit? Decameter cubed, grams per milliliters, meters, or centimeter cubed? And the answer is meters. And then what is the symbol for a deciliter? DCL, DL, DKL, or LD? And the answer is B, uh, D, capital L. If you have any questions on measurement or you need extra assistance, please make sure you're reaching out to me and asking. I hope you now have a better understanding of the metric system. Bye, guys.